This video is all about slope. You know I'm all about that slope. We're looking at a slope of a straight line. Now, a straight line is defined by 2 points. We can call those 2 points just for now x1, y1, and x2, y2, right? If you give me 2 points, then I can give you a unique straight line that passes through those 2 points. Another feature of this straight line is the slope. The slope has many applications, and we'll see those applications in our chapter. We want to first define the formula for the slope. You may already know this from a previous algebra class. We say that the slope of a non-vertical line, that's important there, is defined by m equals delta y over delta x. Now, if you already know slope, you may not have seen it like this, but this delta, that's the triangle-shaped symbol, means change. Right? So when you see this delta y, we're just saying that the change in y, so the change in y divided by the change in x. In other words, we're just finding the difference between the two y values, and that's probably more familiar to you, right? The change in y is y2 minus y1, the difference between the two y values, and the change in x, delta x, is the change, the difference in the two x values. So the slope formula is y2 minus y1 over x2 minus x1. Now we say this is only for non-vertical lines. If we have a vertical line, we have to treat this differently, because if you draw a vertical line, or think about what would happen with the slope, right? The x values are the same. And if you were to try to use this formula, you would get 0 in the denominator, and we know that cannot happen. We can never divide by 0. So in that case, for the vertical line, we're saying that the slope is undefined. It doesn't have a number, it's just undefined, since there is no change in x, and division by 0 is not possible. All right, so I have drawn here on the screen the Cartesian coordinate system with 3 lines, L1, L2, and L3. And let's see if we can find the slope of each line. Let's start with L1 for this, right? So we're going to use the slope formula. Now I have 2 points labeled on this line, 1, 4 and -2, 2. And so we first need to determine which one it will be the x1, y1, and which one will be the x2, y2. It really does not matter which one comes first, as long as you are labeling the first number in each ordered pair to be the x value, and the second number in each ordered pair to be the y value. So just because it doesn't matter, let's just call this point x1, y1, and this one x2, y2. I could have just as easily switched those around, and we would get the same slope, right? And you can try that if you don't believe me, right? Switch those around. Call 1, 4, x2, y2, -2, 2, x1, y1, and calculate the slope, and you'll find that you get the same slope as I do. All right, so the slope for this point L1, we'll take y2 minus y1, which is 2 minus 4. And we're dividing that by x2 minus x1, -2 minus 1. 2 minus 4 is -2. And in the denominator, -2 minus 1 is -3. And -2 divided by -3, that will simplify to give us a positive 2/3. All right, so this slope is a positive 2/3, right? So for every 2 units, the line goes up. The line's moving 3 units to the right. All right, remember that this 2 in the numerator is telling us the change in the y, and the denominator tells us the change in the x. Since the slope is positive, we would expect that this line to be increasing, which it does. Right? In other words, if we're reading this graph from left to right, right, as we go from left to right, the y value is increasing, is going up. If the slope were to have been negative, the opposite would be true. As we read the graph from left to right, we would expect the y value to decrease, to go down. All right, that is line 1. What about the slope for line 2? All right, for this one, I also have 2 points labeled. Now, the 2 points may not necessarily be given to you, but you can look on this line and identify 2 points. That's all you need, is 2 points to determine the slope. All right, so our 2 points here. But taking these 2 points that are given, or any points for that matter, and again, applying the slope formula, right? This is a non-vertical line. It's actually a horizontal line. So let's see what happens when we calculate the slope here. And again, does not matter which point is x1, y1, which one's x2, y2. So I'm just going to pick one, right? I'll call 2, 1 the x1, y1, the 4, 1 the x2, y2. All right, so I'll have y2, which is 1, minus y1, which is 1. Notice that those are the same values. So we're going to end up with a 0 in the numerator, okay? But let's do the denominator first. x2 is 4, x1 is 2. So that is 1 minus 1 divided by 4 minus 2. So 1 minus 1 is 0. Over 4 minus 2, which is 2, and 0 divided by anything, assuming it's not 0, is 0. 0 divided by 2 is 0. So the slope of a horizontal line, right, just going left to right, no increasing or decreasing, has a slope of 0. A horizontal line has a slope of 0. And then for that L3 line that we have, now this is a vertical line going straight up and down. It's not moving to the left or right, just straight up and down, that vertical line. In this case, we could try to use the formula. It is 3 minus 0 over 5 minus 5. But what we'll notice here is we'll get caught by this 5 minus 5 in the denominator. 5 minus 5 is 0. And 3 divided by 0, we cannot divide by 0. You can try it, right? If you don't believe me, many people don't. Plug that into the calculator. 3 divided by 0, and it's going to give you an undefined, or it's going to give you an error or undefined answer, something to that effect, right? Because we cannot divide by 0. So this slope we would just write as undefined. It has an undefined slope. You can think of this as an infinite slope, but when you're typing your answer into WebWork, you would use the term undefined for the slope of a vertical line. All right, so I'm going to let you have some practice here. I have 3 examples here at the top. Take some time, pause the video, and work through finding the slope of these 3. And then you can resume the video and check your answers to see if you got them all correct. All right, so we're going to start with the first one. Again, it doesn't matter which point we're calling x1, y1, and x2, y2. Either one. But we do want to subtract the 2 y values. So I'm going to subtract these 2. I'm going to call this the y2, and at the y1. And then I'm going to divide that by the difference in the x values. And it does matter which order, right? The order must be the same, right? So if I'm taking this y minus that y, I also need to subtract this x from that x. If I go in the wrong order, I'm going to have the correct number, but just the wrong sign. All right, so 8 minus 5 divided by 3 minus 4. That gives us 3 divided by -1, and we can simplify that just to be -3. All right, the slope is a -3. This is one of those cases where with the negative slope, we'll have a decreasing line. If you were to graph that out, it would be decreasing as you go from left to right. Okay, what about number 2? To find the slope, we are subtracting the y values, 5 minus 3, and we're dividing by the difference in the x values, 2 minus a -1. Be particular when you're subtracting these negative signs. Be careful there. 5 minus 3, that's 2. And in the denominator, 2 minus a -1. When you subtract a negative, we're essentially adding those, right? We change that minus a negative into plus. 2 plus 1 is 3. So our slope is 2/3 for number 2. And then finally for number 3, problem number 3, we're subtracting the 2 y values, -2 minus a -4. -2 minus a -4. We're dividing by the difference in the x values, 1 minus 2. All right, here we have -2 minus a -4, right? Minus a negative, we can change that to plus. So -2 plus 4 is a +2, and and 1 minus 2 is a -1, or -2 for the slope. All right, did you get those right? Okay, very good. So that is slope. If you need more practice, turn to the homework and work through more of these examples, more of these problems to make sure that you are consistently getting these correct.